Now the next question that we are going to study is a question 4. So here, as usual, what is our standard practice? Is what a PV diagram and what a TS diagram. So in A part, our target is what? We have to leave what? A space for what? Pressure volume diagram. So what is our first target? What we have to draw? PV diagram. So we have to leave the space for the PV.
Yes.
And the TS. So first of all, please leave the space for the PV and TS.
Yes, sir. Done, sir.
Now what is our next target? What we have to do? We are going to write down the names of processes and then form a table for the number of states, and then we will draw the PV and TS diagram. So here ideal gas in a cylinder is heated at a constant volume. See what is happening here initially is heated at a what?
Constant volume.
So what is first process here? Process 1 to 2 will be what here? What they
constant volume heat addition.
So what is process 1 to 2 here? Is what? Constant volume
heat addition.
Constant volume heat addition. Then
yes.
What is the next process here we have after constant volume heat addition? Then further heated at a constant temperature. Okay. So what is our next process? Process 2 to 3 is what? Constant pressure.
Constant pressure heat addition.
Okay. Constant pressure heat addition.
Yeah.
Then further heated at a constant pressure from 1000 degrees Celsius to 1300 degrees Celsius. So here, so this 600 means what here? This 600 means what? Our T1. This T1. 1000 means what?
1000 is T2.
T2.
And 1300 is T3.
So this 1300 means what? A T3. The change in specific entropy in the first process. First process means what? Which process?
1 to 2.
1 to 2. Specific means
constant volume heat addition.
Yes, here. So delta S 1 to 2 is what? So this is delta S 1 to 2. After being heated, see. So first is what? Constant volume heat addition. Second is what? Constant pressure heat addition. After being heated, what they are saying? Try to see the scenario. After being heated, see this one. After being heated, what is happening?
The gas expands
isentropic. Gas expands. What is the meaning of word expand? Expansion. Gas expands. Expansion isentropically. So it means what? What will be our next process? Process 2 to 3 will become 3 to 4. Sorry. What is process 3 to 4 will become?
Adiabatic.
Isentropic expansion.
Yeah.
So here we have what? How many processes?
3 processes.
3 processes. Not only 2. Here we have what? Isentropic expansion. Okay. Isentropic. For isentropic process, they will clearly mention, oh, it is isentropic or adiabatic. They will clearly mention. So isentropic expansion, 15 times the isentropically to the 15 times to the initial volume means what? What is the meaning of this word? Our V4 will become what? 15 times V1 and temperature of 306 degrees Celsius means this temperature will be a temperature of which point?
T4.
So here we have the names. These are the 3 processes. So before going further, please write down the names of these 3 processes. Now here, as we have 3 processes, how many states we have? We will have 4 states. So what we will do? We will form a table P1, P2, P3 and a P4. So P1, P2, P3 and P4. Then T1, T2, T3, T4. After that V1, V2, V3, V4. In this way. So here in this way we have what? A 4 state first, second, third one,
Yes.
and fourth one. I will make the
Yes.
partition here so that things will become easily available, visible properly. Now what is our target here? Gas is heated at a constant volume. When they said constant volume means for process 1 to 2, V1 will be equal to what? V2. Can we say?
Yes.
So V1 is equal to V2 or V2 is equal to V1. Can we say?
Yes.
And then from which temperature? From 600 to 1000. So 600 will become T1 and 1000 will become what? T2. So 600
Yes.
degrees Celsius and 600 degrees Celsius means what? 873 Kelvin.
Yes.
And T2 is how much? 1000 degrees Celsius. 1000 degrees Celsius means what?
173.
1273 Kelvin plus 273. And
Yes.
then what they are saying? Then further heated at a constant pressure. Constant pressure means what? 2 to 3. So we can say
Yes.
P2 equal to P3 or P3
Yes.
equal to P2. Any doubt in this discussion?
No.
Then, so up to what temperature we are heating the at
1300 degrees
13
Celsius.
from
That is
1000 to
15 centigrade.
So T3 will become what? 1300 degrees Celsius. So 1573 Kelvin. So T3 1573. Change in specific entropy in the first process, that is delta S what?
Yes.
1
Delta
to
is 1 to 2.
0.283 unit kilojoule
Yes.
per kg.
Kilojoules per kg Kelvin.
So 0.283 kilojoule per kg. After being heated, gas expands isentropically to 15 times to the initial volume. Means
Yes.
what? V4 will become what?
15 times of V1 or V2.
V2. 15 times of V2, V4, V2. Same. Any doubt in this discussion?
No, sir.
Then here, so these are the given things to us. And here if you remember what they are asking us, CV, CP, gamma and add one extra part here, R. Add one extra part, CV, CP, gamma and R. Nowadays they are asking R also. So add these two parts, CV, CP, gamma and R.
Okay.
So please form the table before going further. Write down all these things.
Done, sir.
Now what is our next task? What we have to do? We have to draw the PV diagram. So what is our first process? Process 1 to 2 is what?
Constant volume heat addition.
So process constant volume heat addition means what we have seen earlier in our given in constant volume. Straight vertical line upward. It must be go what? Upward. So we will draw one straight vertical line. See this one?
Yes, sir.
It must be in what? Upward direction.
Yes, sir.
So 1. We are going from here what? Point number 1 here. 1 to what? 1 to 2. Straight vertical line. And if we extend the dotted line from here, what we will get? What we can say? V1 is equal to what?
V2.
1 minute, let me make a dotted properly. So here we can say what? V1 is equal to V2.
Yes.
Then further is what?
Constant pressure.
Constant pressure heating. So constant pressure heating means what? So here we will go from what? 2 to what?
Yes.
2 to 3. So here constant pressure heating is what? Pressure constant and volume is going to increase. So here that is what is happening, and we have seen all these things in our theory of the constant pressure.
Yes,
so here if we extend the dotted line from here.
Yes, sir.
If we extend the dotted line from here, what we will come to know that? Oh, here P2 is equal to what? P3. And 3 to 4 is what? Isentropic expansion. Isentropic process.
Yes.
3 to 4.
Pressure reduces, volume increases.
So isentropic. And whenever we want to denote isentropic process, generally we denote by what? PV raised to the power gamma. See, for polytropic process, PV raised to the power n. Isentropic process, how we denote? Here?
PV raised to the power gamma.
PV raised to the power gamma. Okay. For polytropic,
Yes.
PV raised to the power n. That's what we did in last two numericals. That is question 1. Question 1, if you remember our question 1 discussion. See, PV raised to the power n. In question 2 also, PV raised to the power n. But here,
Yes.
but in this question, what we are going to do? If you remember, PV raised to the power gamma for the what? Isentropic process. Okay. So before going further, please draw this PV diagram here.
Okay. So regarding this position of point number 1 and point number 4, is it like the point number 4 will be little bit lower than point number 1?
See, here we can't guess anything about point number 4 because we don't have a pressure of point 4 and pressure of point 1. We don't have that pressure. So don't worry about that point. It can be anywhere. Just show the expansion here. So we can't guess position of point 1 and point 4 here because we don't have a pressure of point 1 and point 4. So we can't guess anything.
That's
Now here, is there any polytropic process here? Tell me, is there any polytropic process out of these three? No polytropic. No polytropic. And we have a temperature of all points also here. Oh, we have not.
Yes,
we miss a temperature of 0.4 here. We miss a T4. Add a T4 here, 306 degrees Celsius. Add a T4, 306. That what we missed here. T4. How much we have a T4? 306. So how much it will become? 306 plus 273.
579.
579.
79.
579. So add this one 579 here. T4 579 Kelvin. We missed that one. So if you observe here no process is a polytropic and we have a temperatures of all points. In that scenario, we can draw the TS diagram in the beginning only. Remember this point. What we can do? We can draw the what? TS diagram at what?
Beginning.
In the beginning only. Huh? See this point. Huh? This is a very important point. You added this T4?
Yes, sir.
So what we have to do? We will start our discussion from what? From what? A constant means what? We will draw our now next point.
Constant volume.
Constant volume. For constant volume process, what we have seen? Slope is what?
The slope is
higher
compared to
constant pressure.
Yes.
So 1 to what?
1 to
2. So this is what our
V. There is the same curve.
Okay. V constant means what? In constant volume heating. If you remember, pressure, entropy and temperature both will increase in case of the constant volume. Same happened with the constant pressure. But here slope is a less.
Yes.
That is what 2 to 3. That is what all these things we have seen now in our 2 to 3. Then so here what we can say, pressure is equal to what? A constant.
Yes.
And then 3 to 4 will be what?
So 3 to 4 this is that temperature will reduce.
Temperature is going to reduce, but it is what? Isentropic.
It's isentropic.
So isentropic means what? A straight vertical line downward.
Straight vertical line. Perfect.
And what is the temperature of 0.4? Tell me, what is the temperature
306.
306.
It is less compared to 0.1.
It is less compared to what? 0.1.
0.1.
So what we are going to do? We are going to do some arrangement here. 306 means is less as compared to 0.1. What we are going to do? 1 minute. So I am going to shift this one. I am going to erase this point. 1 minute. So here we will add a 0.1 here. I have shifted 0.1 little bit. And here what we will have? So this one will be what? A temperature of 0.4 must be what?
Less compared to 0.1.
Okay, temperature of 0.4 is what? Less compared to what?
0.1.
So here we will have a what? A 0.4. and temperature of 0.4 is a less. And how does we come to know that? Over here 306 and 0.1 T873.
Yes.
So if we extend this dotted line further, what we will get?
S3 is equal to S4.
S3 is equal to what?
S4.
Yes, so if we extend this one, you are getting my point?
Yes,
and so
sir.
here, so now before going further, please draw the TS diagram. So now what is our next target? What we have to do? We have to find out CV, CP, gamma and R. What is our next target? What we have to find out?
CP, CV, gamma and R.
Okay, that is what our target. So in this first part, what is our target? What we have to find out? CV, CP, gamma and R. These four things we have to find out in this first part. And how to achieve that one? For that purpose, they have given us what? Delta S1 to 2. What is delta S1 to 2? They have given us 0.2.
Delta 1 to 0.283
kilojoule per kg Kelvin. So if you observe the things here carefully, what is process 1 to 2? Constant volume. And for constant volume, what is the relation of what? Change in entropy? M CV ln of what?
MCV ln of T2 by T1.
T2 by T1. MCV ln of what? T2 by T1. So if you observe the things here carefully, and what this specific entropy, this is entropy, they have given us what? A specific one, this one?
Specific entropy, yes. So mass will be 1 kg.
So 0.283. So here we will take a mass 1 kg. CV, we don't know. ln T2 is how much? 1273. Don't take values in degree Celsius. Take always value in Kelvin here. T1 873. If you do the calculation, we will get a value of CV. Please do the calculation and tell me the value of CV. 0.283 divided by what? ln of what?
0.7502.
Let me check myself once again. So 0.7502. 03 unit kilojoule.
That will be kilojoules per kg.
Kelvin. Kilojoule per kg Kelvin.
Yes.
So before going further, please write down. This CV must be properly in suffix.
Yes.
So this V must be in suffix. So before going further, please write down this discussion.
Answer.
Now what is our next target? To get the value of what?
Constant pressure.
CP, specific heat at constant pressure, gamma and R. So still these three things are remaining.
Yes.
So what we are going to do? We get a... So what is process here? What is process 1 to 2? Constant volume. And process 2 to 3 is what? A constant pressure. So if you remember our discussion, for process 2 to 3, constant pressure process. For process 2 to 3, it will become what? Process 2 to 3.
Yes.
What is the equation of state for constant pressure? P2 by T2 will become what? Not P2, constant pressure. P2 by T2, what will become? V2 by T2 is equal to what? V3 by what? T3. And then see the point here, V3 is equal to what? T3 by T2 into V2. So what it will become? T3 is how much we have? 1573. T2 1273 into what? V2. So we will get a V3 in terms of V2, 1573. 1573 divided by 1273. How much it will become? 1.2357 V2. So now what we got it? V3 in terms of V2. Now what is for process 3 to 4 will be what?
3 to 4 will be
temperature and
isentropic.
And temperature and volume relation for isentropic will be what? T4 by T3 is equal to what? V3 by
V4.
V3 by V4 raised to the power
Yes.
what? Gamma minus 1.
Yes.
So what we are going to take? Taking ln on both sides. Ln means what? Natural log. You can take any log. No problem. Here we are preferring natural log generally because everywhere we are using a natural log. So it will become what? Ln of what? T4 by T3.
Okay.
Gamma minus 1 into what? Ln of what? V3 by V4. So ln of what? T4. How much we have a T4? How much we have a T4? 579.
T4 we have 579.
579 T3.
Yes, T3 we have 1573.
1573. Gamma minus 1 into ln of V3 we calculated in terms of V2. 1.2357. V2.
Yeah.
V4 is how much they have given us in terms of V2? 15 times V2.
Yes.
So 15 times V2. We can cancel this V2 and V2.
Yes.
And then if you solve this expression, we will get about value of gamma. Please solve this expression and try to get the value of gamma. We know we have studied shift solve. Use that one.
Yes. Yes, sir.
579.
1.4, sir. 40034.
1 minute. 1.2357.
Yes, sir.
Is it matching answer? Answer is there at the top. So 1.4003. So in this way, we got the value of what? A gamma. Now remaining things are very, very easy. So before going further, please write down this discussion.
Yes. So a little bit up.
So here we got a value of what? Gamma. Then Cp will become what? What the value of Cp we will have? Cp will become what? Gamma Cv. Gamma is what? 1.4003. Cv we just now calculated 0.7503.
Yes.
So what will be the value of Cp we will get? One point
1.05.
4003 into 0.7503. How much we will get?
1.0506.
06 unit kilojoule.
Kilojoules per kg Kelvin.
Okay, in this way we got the value of what?
Cp, Cv and gamma.
Okay, Cp, Cv and gamma, and then extra part that we added R. R will become what? Cp minus Cv. So it will become 1.0506 Cv 0.7503. Please do the calculation and tell me the value of R. How much it will become? 0.3003 unit kilojoule per kg Kelvin. Any doubt in this discussion? So check the value of R. What value of R you are getting? So please write down this discussion. Cp and R. Now what is our next target? What they are asking us? Change in specific entropy during what? Constant pressure process. So change in specific entropy. Specific. See the word specific. Constant pressure process is what? 2 to 3. So means what? In this second part our target is what? We have to find out delta S for what? 2 to 3. And specific one means what? Mass we have to take a 1 kg. So delta S 2 to 3 for constant pressure process. What is the relation we have seen? mCp ln of what? T3 by T2. So delta S 2 to 3. Mass is what? 1 kg. Cp we have calculated 1.0506 ln T3 is what 1573, T2 1273. Please do the calculation and tell me the value of delta S223. How much value we will get? 0.2223 kilojoule per kg Kelvin, because specific, that's why per kg, otherwise only kilojoule per Kelvin. So in this way we got delta S223 kilojoule per kg Kelvin. 0.222. Okay, we got the correct answer. So before going further, please write down this discussion. Now in B's third part, what they are asking us? In B's third part, what they are asking us? Work transfer per kg during isentropic expansion. So work transfer per kg, yeah? During what? Isentropic expansion. So what is isentropic expansion? W324. So what is our target in this third part? What we have to find out? We have to find out W324. And how to get the W324? What is the relation we have seen? M R for isentropic process, MR T3 minus T4. We have seen T1 minus T2, but here 3 to 4, so that's why T3 minus T4 divided by what? Gamma minus 1. And they said per kg, so we will have a mass is what? 1 kg. RV, how much we calculated? 0.3003. T3 1573. T4, how much value of T4 we have? See the table, 579. And gamma minus 1, gamma we, how much we calculated? 1.4003 minus 1. So if we do the calculation, we will get a what? W324. One 573 minus 579 divided by what? 1.4003 minus 1. 4003 minus 1, it will become what? 745.686 kilojoule per kg. And as we are getting a positive value, it means what? Work expansion. Sorry, work expansion means what? Workout.